Make your class memorable with animations, applications, positivity, promoting events, and so on. I always start with the forum right away, because no matter how often I talk about it, it's extremely important to decrease the amount of email you have. That's the most kind of convenient thing. You just will have so much better experience with your class, with less emails, more time to mentor students, and you create a good community in the forum. So what I do, because it's not that easy to create activity in the forum, it's easy to say, and many of you and me tried and failed. So what I learn, and it works from every semester, is this. I create the first post, which I can share with everyone, and I say a good start is halfway to success. And then I post the initial poster. That in general helps you as an instructor to decrease number of emails, helps students to feel supported and heard. You can get their feedback there, just ask them to be polite and patient. It helps build an active and vibrant student community. I'll talk about it later. And it's just a great place to have fun, because quite often in the classroom, you want to look professional, and you also don't really have time because you teach. So the forum is that place that you can have fun. You can post pictures and animations and memes. And you also can ask more questions there about students if you want. So this is the post I right away post on my forum before the classes start, usually like a week ahead. I say many of you have different backgrounds and life stories, but for the next blah blah months, you will be taking this class and learning as a group, applications in biology, physics, and medicine to like inspire them. To help you to prepare for this class, watch those videos and comment what you think about it. The first video, The Power of Believing That You Can Improve, is their favorite. I do it for 3 years already, and this is students' favorite for sure, and I will share all of this with people if they want. It's a TED Talk talking about not yet mentality rather than I failed. Oh, I failed the class. No, you just did not pass it yet. Or I cannot understand integral. No, you just did not understand integral yet, and you will do it later. Then I also found video that helps them to actually plan their studies, and they like it too. So motivation, self-regulation, and learning how to learn. And we all know that many of us students don't know how to learn, surprisingly, which you kind of think they should after high school, but not really. So this helps them to structure their life. And then I also post, recently I added some specific details, your thoughts about the videos and topics you saw. What are your expectations from this class? What is your major and why you chose it? And any advice for new online students on how to do well in online classes, for example. Then I always say choose some fun avatar for the forum, because in Canvas they have professional ones, so at least should have something fun in the forum. And the forum blows up, especially if you started early, a week early. There's no homework available. Modules are open. They can start watching videos and reading. You don't have to read this. It blows up. People love sharing about themselves. They did not share as much before until I posted the more detailed questions. So now they share their major, why they chose it. Are they scared about this class? What are the expectations from this class? Why are they taking this class? What's the recommendation? Someone who is taking the class a third time will mention that and say, this is my third time, and I recommend not to get behind on the exam one. It's the hardest one, or something like that. And to promote it, of course, you offer extra credit. So I offer extra credit top 10 in 100 class, student in top 20 if it's 200, top 30 if it's 300, because I merge all my classes that are the same into one forum. So I had kind of close three of sections together in one forum with 300 people, and it was amazing. They really loved it. And I said, you don't have to be good at math or in this class to get this extra credit, because you just like each other's posts, and I don't choose who gets it. Based on likes, which are hearts in our post right now in a discussion, they get at the end extra credit. And I always say, help each other, be supportive, be polite, be positive. So if someone is negatively commenting something, I usually comment, please be positive in this class. So then when I start my first day class for in-person classes, I always ask about their hobby, and always make a comment, don't put sleeping, because someone still does. And people share their hobbies, and then I keep it in the forum, and I show them, this is how you post your homework. So I give them an example of how to post the homework after this hobby question, and then they will continue later in the forum talking about their hobbies, and now they connect with each other. They connect with each other either through majors, or through things that they just mentioned they do for fun. Computer games is the most popular, or Sudoku or dancing, and now they start connecting to each other. If they are on campus students, then they start creating groups, which was the most impressive part in my mind. They mentioned watching football, video games, thrifting, photography, and so on. And if I don't recognize any phrase, I just paste, I just post the question, what is that? So it's also very educational. And I like everything, so they can see that I am active there. And that's like the first week is super important to be active in the forum. This is my smaller class of 160 students. There were two classes merged in summer, and yet we had 1,000 comments just in summer, which is what, 6 weeks or less, and 33,000 views. As you can see, it was extremely popular, extremely active, and students just fell in love with it. But to make it active, you need to push for 2 weeks not to answer any homework questions via email. You have to be very consistent with that. You will receive questions, of course, either through ad discussion, it forwards to you, you can turn it off, or through email. And you just say politely, this is a really good question. Can you please post it in the forum? And I will answer it there. Moreover, you can post it anonymously. And that's when they finally start doing it. If you don't mention the anonymity, they will not post if they don't feel comfortable. So you should mention it, and then they're like, fine, I don't lose anything. And then go and actually answer there. So they see you're consistent. And you do it for 2 weeks, because for 2 weeks you will be receiving emails. And then they stop. The emails about homework just stop for the rest of the semester. It's exactly that impressive, because now they see that the answers are happening already in the forum. In every single class, you open the forum in your class and you show it. You show the questions, you show the answers, and you see people discussing. Go to the forum if you still didn't do it. If it's online class, resend the invitations somewhere in the week saying, hey, you're missing out. And also there's extra credit there. And that's how for 2 weeks you kind of push it, and then it just plays for you. And also I have a TA, the IA, that helps in the forum too. But when I have many students, they just help each other. It's just amazing environment. There's always people who know what to do, and they explain each other answers in different ways. So it's really good. And I just look through, I like everything. And sometimes I post motivational comments saying, good job, amazing, very well done, good logic, and so on. Then I created an extra credit for top 3 memes. Well, it's a tiny one. This is the one I never mentioned how much is it. But for the forum, I do mention that it's going to be 1 total percent of the grade extra. This one is a tiny one for some kind of homework, whatever they don't have perfect at the end of the semester. So I say there's so many good memes in math. They have to be related to math. And people start making memes about me, which was also pretty hilarious. And I always liked them and supported it. So someone says, one does not simply take Professor Julia class without participating in a discussion. And that motivates them to participate even more, and also makes a kind of relaxed environment. Now they know they can ask you for help. So my favorite meme personally is this one, especially after COVID. When you wake up late and you missed your class, the first day after break, you panic, then you're like, oh, it's fine. Professor will record the lectures. You come and you're like, oh, shoot, you are the professor. So you panic again. That's my definitely favorite ever. Students post a lot about exams and how hard it is. And you just go there and you just laugh a lot. And surprisingly, such a simple, silly idea made a big difference for online students. They, again, making their own. Instead of working on homework, they're creating new memes for my forum. Online students were mentioning that some of them are grown-up people with 2-3 kids and full-time job, and they never enjoyed reading memes that much in their lives. So I have got really good feedbacks in the last 3 years. So you never know what's going to work. That's my point. You think maybe it's silly or waste of time, but actually you never know what people are going to like. So it's why not to try. Well, I made this like fancy boxing thing. It created groups, which are creating groups to meet outside of the classroom, outside of the forum and classroom. They start building groups, and they reserve the room or library. I reserve room for them if they are on campus, and they start meeting there. Of course, they have also the other forums without me. We all know that, Discord and stuff like that. And they share those links. Then they start posting about interesting math applications or news. I had PP students just posting about applications on automatic cars or video games. I was like, wow, that's amazing. They also start posting notes they make. And they ask me first, is it okay? Like, sure, post your formula sheets, post your notes. They start making that. And some students start relying on those posts. And they were so grateful to that student and saying, please keep posting. We love it so much. And I always mention that I don't proofread it, so it's up to you guys to use it or not. But I love the communication between kids. That was amazing too. Sharing struggles that they have. I usually ask, how is it going? Who's struggling from the hurricane? Relocations, work, and they share. They share their things. You can share yours. If you don't feel comfortable, you can just support them sharing it. And again, being supportive. And then students see that you're supportive, they being supportive too. And you can see it's amazing conversations. They text to each other, you got this. Like they don't know each other and they will never see each other if they're completely online. They're located in different states, some in different countries. Some we had students in the submarines because they are serving in Navy. And they saying, you got it, John. Like, you got this. Keep working hard. I'm so sorry it happened that you got sick. And they were craving those interactions with peers, for sure, especially the grown-up students, the one that we have with the families, and they go back to college. They don't know what college is. They forgot or they never been there before. So they love this the most. I highly recommend you do that. They need to connect and they want to feel this community of education, which they cannot have it at home because they take in class online. They still go to their work and they still have at home the chores and kids and other things happening, deadlines. And suddenly this is their place to connect with each other about math and about the class they're taking. So I received lots of good feedback specifically on this, that the forum was the major part of all the classes I taught. And I highly pushing it. It's just so much better to teach with it because you do less work, but it's more optimal. It's more, it brings more to students that we think it is. So just trust this and keep pushing it. If it's not working, just keep pushing it to students. Here's the picture I found. That's the forum is helping students to connect and they create communities. At the end of the semester, I have students crying in the forum saying that I really hope someday to meet some of you, or Jacob was amazing and Samantha helped me so much and Lee helped me so much. I hope to meet you someday, but we're not even in the same state. People were crying in the post. That's how great the community ended up to be. And they shared each other phone somewhere in Discord and hopefully stayed in touch. So that's amazing. Exactly. My cat is meowing. So I teach right now a class that has discussions, which data science and ethics have lots of problems and questions about ethics and morality of abusing statistics and data. So once per week, we have debates, 3 students versus 3 students. They prepare ahead of time, pro and con. So just yesterday, we had this debate on AI in job recruiting, sourcing for candidates, screening candidates, interviewing. Is this ethical? And what are the benefits and harms? So we had pro and con, and we had all those debates. And not only forum helps them to communicate with each other, but also moving away from the forum, but in-class activities, I started using more things for them, like Slido. Many of us know Slido.com, because it's extremely easy to create. Many of us don't want to use anything new because we're already busy with everything we do. We have 4, 5, sometimes 6 classes with 500 people. So when I learned how easy it is to use, that's what got me. Because if it takes more than 3 steps, that's already too much at some point because you're behind on some deadlines. It's super easy. So this is my favorite one, which is like those words that become bigger if they are popular. And I just ask one question, give one word of what you just saw today. And in my case, it was a discussion. One word, how would you describe today's class? And I would do it at the end. So I did it to other classes too. And it's just so fun when you teach derivatives, which is at the end, one word, how would you describe it? And I would say hard, impossible, interested, curious. And you leave it and they don't leave the class. They actually stare at this, how it's keep piling up and growing. And so we definitely agree it was very unusual if that AI is biased, but not AI, which are humans, also biased when it comes to looking through interviews and recommendation letters. But it's an interesting topic, intriguing. Someone was super sleepy from night of preparing for exams, so they were honest about that. And we just, someone it was intimidating, because students will go to the job market soon, and they were intimidated by all of this. This is so convenient. You just scan it. This is how you present it. There's a thing, they take the phones, they scan the answer. Super simple. And then after this, if you continue class after this, then you tell them, and now you're doing an exercise. You grab your phone in your right hand, stretch it up very high, and put it away. And then they put it away. So, and then you continue the class. So if you do this as a break in the middle of the class, which is even better, because people get sleepy in the middle of the class, so it's nice to kind of wake them up, then they can give you some feedback. And polls, of course, Slido has everything. So Slido is free, ASU provided this for us. So you don't even need to create an account. It just syncs. It goes through ASU right away. And we had some activity about whom to save from the sinking boat, 8 people out of 20, and they voted. So that was pretty cool. And that's how we collect data. And we talked about data collection and biases and statistics and biases if you don't have enough data and stuff like that. So it's super cool. And I do those votes on the class. Was the class hard? What is your favorite topic of the class? Integrals, areas, arc length, and they would vote too. So it's kind of fun to put it on a screen. And sometimes I do the poll that says, what do you think about the exam that we just had? And they would mention what they think. Or what do you think about the exam that is coming soon? And they will say something too. So that's what you call checking on students and taking temperature of the class. I always promote visualization, as you can see. It's fun to show something moving. And what I do, I come to class earlier and I put this on the screen and just don't say anything and just do my stuff, prepare my laptop, and they just look at it. And that is so fascinating. And they got used to it. Every time they come, if they come early enough, they will see something fascinating. So I show them cool things. No matter what class I teach, I show them a hypersphere, because why not to show a hypersphere in any class you teach, even if it's not a math class? I show it into now to math classes too, because I was just teaching in OLI program, which is teaching to our group of students who are 50 plus, they taking classes. So I show them too, like everyone loved hypersphere. And then if you want to know how did I found it, you just go to, let me see if I can show you entire screen, right? Yes. So I want to try to show you my browser. Do you see my browser? Igor, I'm looking at you. Do you see my browser? Yes, no, yes, no.
Yes, I can see it. Yeah, thank you.
Okay, thank you.
Yes.
Because sometimes it's not sharing the browser. So I just go to Google and then I just search hypersphere, usually with typos. And then I see cool pictures and I like them, why not? But I always go to tools and I go to types and GIFs, and then you just find cool things and they keep adding. So whatever I see this year was not there last year. So you can use this. That's how you find things. It's just super interesting. And you don't have to do hypersphere. You can do hypercube or whatever you're teaching, which I'm going to show in a second. This is already pretty cool. You can use it as the avatar. And you can find the moving ones if you want. Here you go. All of this can be saved on your computer and reused later. And I always use it in my announcements, why not? With a link to whatever, Wikipedia, whatever it is. And I always use it in my icons of Canvas classes. So all my Canvas classes are moving. They all have something happening. Either some kind of cool animation. Here's my data science class is also moving. Ethics and data science. So it's in settings. You can upload instead of picture, you can upload a GIF. So they're all moving. And I like that a lot, obviously. So that's how you find interesting things. And students love it because I can tell you, no matter which class I teach, I found lots of cool things. Let me go back to this. Yes.
Mhm.
For example, vector fields. Look at how they float, and you just leave it on the board and don't say anything and the class starts, and you can go back to it later and mention what was it for. You don't have to mention if it's calculus 1 or pre-calculus, still put it there and say, we're going to learn about winds or magnetic fields. If you guys stay strong, keep working hard, we're going to learn this. I mean, line integrals is the best thing. I show it to all kind of level of students, without going into details. And I always mention through hiking, which is kind of, everyone loves hiking, especially in Arizona. How do you hike from B to A if it's not flat? This is how it works. And so they get so fascinated by this, no matter what level of math it is. It's just these animations are very visual, and you promise them they will understand it in the future. And it's just super beautiful. Add your thoughts to it if you want. And then you show integrals and show them all of those are integrals. That's what we're going to learn today, definition of the integral and whatever, or in the next class. So all of this is pretty fascinating. Most of them mention video games as their hobby. So it's just asking to find something about video games because you want to find something they're interested in. And then I always say, oh, triangles are used in video games, not rectangles. Why is that so? And there's lots of articles about that it's easier to manipulate triangles when the face is moving or the water is moving. It looks like that. So you can send the links and you post it in the forum if you have time. Sometimes I don't have time to post those things in the forum. And sometimes I ask students to find something new. And I say, if you find something new, I will show it in class. And some students do. Gradient, of course, you can mention it to any student of any level, what hiking is and how is it to go hike from top to bottom with restricted vision and blah, blah, blah. Promise they will learn in the future if they take more classes. And the basic classes, I showed it last time when I was presenting derivative, definition of derivatives. We're teaching all of this with nice pictures, but there's so many animations now. Just leave it on the board. Then give your class and ask questions, but then put it back and say, okay, do you see how it's moving? Now you know what it means. So I like that it shows up twice or 3 times. First, when they don't know what is happening, then they saw the definition, and then third time, maybe you have time to show it next time again and say, do you guys remember this? And they will say yes. Zooming in, linear approximation. So people keep coding those things, and now they just keep showing up more and more because I'm doing it for 10 years already. I'm using animations since I started teaching as a TA, and now they're just so much more in the internet. You can find kind of whatever you want. It's probably going to be even more with AI showing up and doing visuals. So this is like, the thing. We know that the programs can do the folded boxes, but sometimes I'm too lazy to do it myself. I just leave the box, especially before the class. You just leave it. It's happening. People have no idea what is happening. And you're like, oh, we're going to find the volume of this. So it's all kind of very interesting. I love talking about chain rule in deep learning, backpropagation, machine learning, image processing. I mentioned lots of chain rules, so we need to learn that if you want to learn machine learning. And of course, they all love this phrase, machine learning, data science. Like, oh, your phone is getting unlocked with your face. Well, do you know how it recognizes your face? Through chain rule. And it's just like you don't go into details too much. You just tell them this chain rule is there. And it's so fascinating for them. Then you say, oh, those called partial derivatives. That is cool. That we teach that in calculus 3. And then you show them partial derivatives, and they're like, whoa. And then you say, yeah, you'll be doing this for the exam too in calculus 3. And then you show them this is how it works. This is how it recognizes your face. AI goes through lots of levels. Lots of levels have hidden levels and chain rules happening on the way. And that's how it recognizes the image. Then I found more stuff, just like I showed you with Google and GIFs. I just found more things. I showed them, see, the person is visual. Computer thinks 97% it's a person. Dog sometimes is hidden, so it's 33% as a dog, but then goes up to like 90% when a dog is outside. And the guitar is always a guitar, but it doesn't really, oh, it's a couch. And the couch is probably a couch, but maybe it's a bed, so it's 40% sure about it. And tell them, you see how cool is that? And this is done through chain rule and math, and they just get super happy about it. And then you go back to calculating derivative of sine of 2x. So it's nice to have this like mixture of technical, boring things, repetitive things, with amazing graphs, some animation that have nothing to do with whatever you're doing today. Why even bother connecting it if it's just interesting? So it's nice to do it in the middle of the class. The statistics says like 20 minutes is the best, for 25 when people get super sleepy. It wakes them up, and then you continue. Now there's more animations and videos of recognition of driving cars and humans and commercial. So the feelings, how accurate the program is. And I show more math because I know a person who was working in automatic cars, which is Janie Gong from our University. She graduated from us, and she was a lecturer here too. And now she's a professor at the Amherst College. So she's still working on those things. So I show students that when they work on automatic cars, they do lots of partial derivatives, lots of sums, lots of integrals. It looks like that. This is from her research, how they identify how there's lots of noise happening. So it's data collection, data science, and they do collect data, of course. They do collect lots of data, and then they analyze it through coding and proving theorem. So they have definitions and theorems. So it's pretty cool to tell students that there's lots of pure math is happening in applied math, and lots of proving, lots of integrals. So I always put this meme after that. Students who want to learn machine learning are super happy. Computer science is super happy, and it's like math proofs are hidden inside, and they don't know about it yet. So this is her team. I always like to brag that this is our graduate, our colleague, Janie Gong, and there's a huge list of sponsors working on this team together, collecting data when they drive in those automatic cars through highways during the traffic. And then they prove theorems. And that is something I like to talk about because it opens the eyes that we teach those classes so that they can reach this level of this. Because Janie Gong, as a professor, also reached this level through learning what is derivative of sine of 2x. And it's nice to connect those things, that those are not some people who were born to prove theorems. We all went through the same training, more or less. And of course, I want to skip this a little bit faster because I like to show it often already. Solids of revolutions, the best thing is to show them how actually it happens in 3D. This one is too slow. Show them something old, like sines and cosines, as a circle over there. Show them something new and unusual. It doesn't have to be practical, it just have to be cool. And leave it on the screen and see what they're going to say about it. Show them something more interesting. Of course, it has connection with Fourier transform and so on, and you don't have to mention if you don't want to, but you can if you want to. Show them more stuff. This is something they know, but it's just very confusing and overwhelming. But you can review if you want. And just leave it before the class, let it run. Let it make people dizzy with all the colors and stuff. But all of this, they're supposed to know that. Then I usually go to Wolfram Alpha, and there's a stuff there called popular curves. I just search it, Wolfram Alpha popular curves. And they have lots of curves, and I always show them. You see those sine, cosine, vertical shift, horizontal shift, and stretch. Oh, those are curves, transformations of graphs. I said, do you guys remember we learned the calculus class? No matter what class is it, I always mention. And I said, yeah, that's how you draw anything you want with sines and cosines. And I show them that. And I show them, if you go to 3D, what do you think is going to happen? And like, oh, it should be a spiral. Like, yeah, it's a spiral. We're going to learn in calculus 3, helix, DNA is a spiral, and helix, and I talk about that too. So they get super curious about those things. And again, you can leave it there, or you can do it in the middle of the class. Like, oh, let me show you some cool animation. So my students got used to it that I say a phrase. Oh, I found something cool to show you. It becomes a small 3 minutes break in the middle of the class. So I show them that to connect with what I just said. And recently I Googled for my presentation about music. I realized I should connect to something that people all know. Computer games for students, obviously, and music. So I found that a spectrogram of violin waveform with linear frequency on the vertical axis and time on the horizontal axis has intensity coloring as logarithmic function. Like, how cool is that? So that's a spectrum, is a visual representation of a spectrum of frequencies as a signal as it varies with time. Then I found that like lots of matrices are involved in music, which is not very surprising to me, but it's useful to represent all 4 transformations of a row in each of the transformation in the matrix 12 by 12. So I show them that, and students love music. Many people will feel happy about this. I found a program that actually puts it in the music box of the matrix, and you can follow it. So it's called self-similarity matrix representation of music has been shown to enable identification of structural and rhythmic elements. And actually, if you click it, it sends you there and plays the music. Let me see if you guys have seen what I think. And then you play it. Well, not only it connects with notes, which is pretty cool too, but also it plays. And when it plays, it shows the exact location where it is. And there's two pianos here. So they show both. And you can find the location. It's like you connect it to Matrix or you don't. You can just say that this is awesome and then move on with your class. That's my point. It doesn't have to be specifically connected to the material. Just making the class memorable, I think, is pretty good. So that's kind of my point here. There are books published called Music Theory Matrix and Bass Matrix. That's pretty cool too. And of course, the Fibonacci sequence, most students recognize at least the phrase. And show them how cool it is in music and geometry and so on. So there's lots of ratios happening, divine proportion, definitions. And again, back to music, check it out. Fibonacci sequence is in piano, consists of 13 notes. And apparently they go to exactly perfect Fibonacci sequence. Anyway, so that was surprising to me because I did not know that. Then you divide and you get the golden ratio. So send them the link, let them think about it, let them post something new in the forum too. So all of this I keep connecting to the forum because that's kind of the golden ratio in my classes. Everything goes back to forum. Composers were using it a lot, like Mozart, for example, used golden ratio for his piano sonatas and so on, and they thought it makes it better. So there are also some other cool things like exposition and music and so on also have golden ratio. How cool is that? So Mozart was arranging on purpose his piano sonatas for that. And I did not know that the violins, for example, the Stradivari favorite violins has a golden ratio everywhere. So some scientists think that that's why it's has a perfect sound. And the golden ratio comes from the Fibonacci sequence used for saxophone mouthpieces and speaker wires and acoustic designs of some cathedrals. So that's pretty cool that cathedrals use acoustics through the golden ratio. Then I found this. It's called root proportion, square root of 2, square root of 3, and so on. And I was like, wow, this is so cool. And I showed students the circles. And I asked them if they know what this instrument is called. And that is nice to promote some diversity in your classroom. Some students will recognize it and say it's oud, and where it's coming from Middle Eastern Arabic instrument. So it's also pretty cool to promote that. So oud has golden proportion between handle and the side. It's a root proportion. So that was also interesting to me. You have engineers in the classroom, so it's cool to tell them how important all of this. So I found those pictures from some book, Geometrical Method for Sound, Hole Size, and Location Enhancement in Lute Family Music Instruments. So that's pretty awesome, I think, too. Finally, I found that there are mathematicians that are also musicians, so they use math in the music. For example, Bruno is using category theory for a basis of music theory, and includes using topology as a basis for a theory of rhythms and motifs. And differential geometry is the basis for theory of musical phrasing, tempo, and intonations. I found that's pretty cool too. Then I just wanted to find more. So I went to ChatGPT and I just asked this question. Actually, we'll go back to the phrase. Let's see, I lost my presentation. Too many things are open at the same time. I'll just go back here. I just took the phrase of mathematicians and musicians at the same time. What I did, I asked ChatGPT to find me the list, and it did. So now I'm kind of using ChatGPT for that. I feel it's pretty fascinating. So I did mathematicians that are also musicians. And just make sure I'm sharing the correct thing. Yes. Then I went to ChatGPT and I said, find mathematician or list. And it did. It even explained all those people and what did they do, and what music they did. Albert Einstein. I did not know that. I knew some of it, but I did not know that he often played Mozart and Bach, and Mozart has golden ratio, so you can connect that. So, please, but remember, you need to proofread the facts, because there's a joke about the AI. AI is not necessarily giving you truthful information. AI is taught to give you the fastest and the most optimal information. It's not necessarily true. So you just need to double check if it's correct. But that's one of the ways I just learned to speed up my process of finding those things. So sometimes it's just too time consuming. I can share all of this with you, but of course it took time to find this. Finally, I like to promote math awesomeness in different ways, like showing it in different languages. I just leave it on the board and say, "Do you guys can you read it?" And usually people say no. Maybe one student says yes, but do you know what they're talking about? And students will say, "Oh, this is integration by parts, so I do calculus 2 and calculus 3." I'm like, "Yes, you see, math is an international language, and that's why I came here too as a mathematician. I was able to learn English a little bit, and then went to grad school, blah blah blah, because I know math. How about this? Can you read this?" Most students will say no, and then someone will say yes. "Do you think you know what they're talking about?" And they look at it carefully. And someone like, "Oh, is it like fractions?" I'm like, "Yes." "What kind of fractions?" And then, "Oh, partial fraction decomposition." So this promotes all of this. And I always mention that they should try to travel with a knowledge of math. They can go to other countries as exchange students, especially since they know English as a first language, most of them do. So I love that too. That's just from Wikipedia, super easy to do that. That's Ukrainian, if you did not know, by the way. And then when I was out of ideas, I just made the posts like show your paths. It's like that. I was just kind of like, what else should I post? This is super short. This is literally 2 phrases. I said, show your paths. It's time to show off. And people start posting their pets, no matter what they wear. We all, of course, expected cats and dogs, but then the horses showed up and the goats showed up. So then we had like favorite people in the classroom, like, "Oh, who did the goat thing?" And people would raise their hand, or online students. So that promoted just a really fun break after the exam, or whatever was it. But it was after the exam in my case. It just was out of really ideas. But sometimes I do ask them, "How did you feel about the test?" "I felt confident. I could do better. I got lost. I got scared." "What is your favorite topic for the exam that is coming?" Most people voted for work problems. That's exam 2. Volumes, integration with tricks, and the least favorite is partial fraction decomposition, surprisingly, because I think actually they like it. Power series, nobody likes them, too hard for them, or whatever. How about the homework? So I ask those questions from time to time to check the temperature in the class. That's what they say. They keep an eye on students. Finally, I always mention that try to promote and recruit students to things that you think are interesting. I always promote AWM, Association of Women in Mathematics, to everyone in the classroom. And that's why I keep in touch with my students, because they go there for many years and I go there for many years. So my freshmen just graduated recently, and we were having tea together and coffee, talking about them getting jobs, and they got jobs. Or we have math clubs and different talks, promote that. I sometimes take pictures with them and we post it in the forum, and that promotes other people to come next time. So it's like becomes like a whole kind of collection of events. Finally, promote the school we have before the class, after the class, during the class. You choose. Calculus 3, it was hard to find time. It was always too fast. 210 was hard to find time. But in some classes, I found time in the middle. If not, I did it before the class. And I promote, I say, this is what things we teach, and you can get degree in this, and you can get degree in that. And what is actuarial science? Does anyone know? Here's a tornado we're afraid about so much. Do you know that actuarial science has connection to that? It's probability, it has connection to that, and so on. Finally, if you receive the email from our school, and we do receive them often, about scholarships and jobs, post it. They will be very grateful, because I did receive lots of emails saying, "Professor, you actually cared about us getting jobs." Someone actually posted, "I love how the professor is always trying to help us to get a job." So I found this meme, with Oprah. You get a job, you get a job, you get a job. So they actually did get those jobs. I posted lots of different things, and summer research, RU, and so on. And then at some point I had more time. I started promoting more things I always wanted, but it's like there's a thing to find time for that. So promote diversity for sure. And I started collecting some cool stuff through women mathematician, Hispanic mathematician, and they loved it a lot, especially Hispanic mathematician, because we have lots of Hispanic students. So I just realized we never mentioned those things, and we should do more. So they feel inspired and they feel that they can, that is important. Finally, promote our own people. Like we always receive email with congratulations. So we just received a recent one, if you remember, and mention that, show the person, say it's our person, Elena, and so on. You should be proud, but also it's cool to show them those are real people and look how awesome the topic is. Like Alzheimer's disease, tell them, can someone find something and post in the forum? Maybe they will not do it. That's fine. Don't be upset. Just a cool idea. Oh, I had a text here. So I found the definition of the mathematical model that predicts the behavior of A peptides and Alzheimer's disease in the brain. So, and I said, this is how it looks. Ta-da! And I found the equations for that. And I said, look at these derivatives. You guys can do it. Go figure out some summer research or training or internship. So, and I said, those people probably do some summer research with undergrads. You guys should check it out. And they do, they contact them after that. Maybe they contacted you at some point. Then just recently, honoring Hispanic Latin American achievements in mathematics. Here you go. This is our own presidential postdoc, Dr. John Pons. She was honored by SIAM in celebration of National Hispanic Heritage Month. And she says, surround yourself with peers and colleagues that are mentally enriching. Those connections will not only broaden your perspective, but also spark new ideas and opportunities for collaboration. So you show it to students and you inspire them. It's those little things matter. Try it. Like prepare it once and reuse it from year to year until you find more time to update it and find something new. But you don't have to. Even something already done before, just show it again. Why not? So that saves lots of time for you, but it brings those cool things into the class. And I always finish. Oh, I think I have this one. I'd like to finish. I'd like to add stuff about space science, and we do have graduates who work for NASA and Los Alamos Lab, like Wendy and others. So we mention that a lot too. I mentioned Mayo Clinic because we have lots of connections with Mayo Clinic. I show a cute video about the evolution of bacteria and how integrals help with that. Lots of different things. Usually what I found interesting, but you can always change to something you like or something that you never thought about. But space, everyone likes space. So I talk about black holes and explosions and supernova. Calculus 3 has lots of options for that with vector fields and so on. But I always mention in any class, pre-calculus, calc 1 and 2 and 3, discrete math. I just talk about space. Just space is awesome. So you kind of bring that awesomeness in your class. And then I just to mention more funny things or more interesting things and ask them to add whatever they want. So when I read my evaluations at the end of the class, I see all of those things there. Because you never know. Maybe like you're talking to a wall, who knows? But actually I do. I see people mentioning those things in the evaluations. How they like that specific one thing in biology I mentioned, or the cars, or the vector fields. They remembered something. And I feel like that is pretty cool. That means like the whole general feeling of the class end up to be good, interesting, fun, supportive. You brought more ideas to them. Most of them don't think about math as something applied, even though literal examples in the book have applicational problems. They think it's fake. They think that calculating exponential function decay through the antibiotic in the blood is a fake example. No, bring it to them. Bring them how Mayo Clinic works with neuroscience and how we work with Mayo Clinic through our graduate students, and show them those degrees I just showed and say you can be part of this project in the future. There's lots of things to talk about. So find a little bit of time, use my ideas if you don't have time. Or any of this is fun, and you will see the students will be super grateful and will give you this full feedback that they remembered your class for not just integrals and derivatives, but also interesting stories. And students love the stories. And that's all I have. Thank you. Let me know what questions you have. Questions, ideas, comments. Let's see, there's something in the chat. Thank you.
Thank you. Thank you very much.
Yeah, I think I will share the slides so people can use some of these ideas. And don't be shy to ask for more. And that's only one person. I'm only one person who's sharing what I do, but we have so many other people who use more programs, more interactive programs. I watched their classes recently and I was very impressed by that. So I did not get into those yet. Yellow Dick is one of the examples of interesting tools to use online. So if you have more motivation, you learn more things. So this is what I do, and I feel like that is the least time-consuming thing I did, and it's somehow had a really good feedback. So that's why I like talking about that it is doable. Well, thank you. Okay, that's nice. If there are no questions, so we can just go back to work, which
Thank
is nice
you.
too. Yes, thank you so much for coming. Thank you.
Thank you. Bye bye.
Have a good day.